This is just going to be a video to cover a few conversions. So here I've got a Paint application just opened, and we'll look at a few of these questions and see the process used to answer them. So the first question is to convert 15 feet to centimeters, and we have the conversion factors. 1 foot is 12 inches, and 1 inch is 2.54 centimeters. So the way I like to set this up is to use, and you would do this via handwritten method rather than a computer method, but I like to set these up with a series of bars that sort of show us where the denominator and numerator are going to be. So I go to the original question and I look at what I've got, and so it's 15 feet. Now the 15 feet will go here. And then this is going to, it's going to have to be matched with a feet unit at the bottom. So I know that this bottom part must have feet. In other words, if I have the feet at the bottom here, I'll be able to cross off what's on the top. And so then I look for my conversion factors. And so 1 foot is 12 inches. So the 1 foot part must go on the bottom. And that's matched with the 12 inches. So left at this stage here, we can see that the foot is cancelled. And I could put a line through there if I wanted to. So maybe I'll just do that to demonstrate. You don't have to do this, but that way these feet would be cancelled, and then I would have the 12 inches, just the inches for the units. But we're not done there because the question's asking to convert the feet into centimeters. So then the next one of these bars that sort of separates the numerator and denominator is drawn. And again, we want to cross off these units. So if inch is in the numerator here, I have to have inch in the denominator in the next one. And so again, I'll look at my conversion factors here. And so 1 inch is going to be equal to 2.54 centimeters. Okay, so that's enabling these two to get crossed off. And we just double check that the units we've got currently are what we need. And again, we need centimeters, so we should be good with that. And then we just go ahead and do the calculator. Okay, so when using the calculator, what we want to do is to multiply all of the numerator values together and then divide and then open a parenthesis and then multiply all the denominators together, close parentheses, press equal. In this particular example, we don't have anything other than ones in the denominator. So really you don't even have to worry about doing that for the denominator part, but other problems will have to do that. So if I put in my calculator 15 times 12, I get 180, then multiplied by the 2.54, and I get 457.2. Centimeters. Let me just try it again. Yep, so 457.2 centimeters. And we need to now consider our units, our significant figures. So one thing that students often get confused with is when they're looking at the conversion factors themselves, they may think that because it's saying 1 foot or 1 inch, that this is just one significant figure. But when you're looking at conversion factors, the one is saying like one exact foot is then related to some other conversion part. So in this particular case, this 1 foot is actually by definition equal to 12 inches. It's never going to be 12.01 inches. It's just 1 foot is 12 inches because we know an inch is a 1/12 of a foot by definition. So that one, this is an exact number. And actually this next number as well isn't 3 significant figures. It's that 1 inch is actually by definition, and this doesn't happen very often with these, but by definition, that inch is actually defined as 2.54 centimeters. So this is actually what's known as an exact number. So in a way, these conversion factors are infinite infinite significant figures, because this is the way they're defined. So when we look at the problem itself, it's only got 2 significant figures for 15. So I'd have to report this answer to 2 significant figures. And 460 would certainly be okay. Let me put another equal sign there. So 460 centimeters would certainly be okay. That's 2 sig figs. If we had the decimal point there, that would make it 3. So if it was 460 with the decimal point there, that would make it 3 significant figures. But as it is like this, that's 2 significant figures. And of course, the other way to do it would be to use what we call scientific notation. So that would be 4.6. And then to work out what power of 10 we'd have, it would be, if we did just pretend there was a decimal point there, we'd move this across 1, 2 to get to the 4.6. Again, if there's a decimal point right there, you move it across 2 places to get the 4.6. So in scientific notation, this would also be 2 significant figures. Moving on to our next problem, we've got 55 pounds per gallon. So now we have units in both the numerator and the denominator. So the best way to start is to draw these things, but if I just put the number in here first, I'm going to have 55 pounds is going to be our value for the numerator to start off with. And I'll draw in these things. And again, you would want to do this via handwritten approach. Okay. So it's 55 pounds, and then there's a gal in the bottom. And you could write 1 gal if you like, or just gal, fine, for gallon. And so now, when I start doing my unit conversions, I've got to remember what I want to cross off and how to approach that. So first of all, let's say we wanted to work on the gallon part first. I know whatever I'm going to use for a conversion must have gal as the unit in the top. Okay, there has to be a gal in the top part because that needs to cross off with the bottom. So how many gallons? Well, we look at what's related here. So the conversion factor is 1 gallon is 3.79 liters. Okay, and sometimes it's not immediately apparent where you're going with this conversion, but we know we do need to cross off the gallons. And when I look at it, I'm going to be dealing with milliliters in the final answer. So even though the conversion factors don't mention milliliters, they mention liters, and you know that's going to be related to milliliters anyway via a conversion of 1,000. So we go ahead and put this in. So we have our 1 gal. Okay, and I'll just move this over here. The 1 gal is equal to 3.79 liters. Okay, so we have that. That's our part there, and I'm going to continue working on this volume part till I get that sorted. And then we can move on to the mass part of it. And so, like I said, I can tell that this liter part is going to be able to be converted to milliliters. And so even though it's not in the conversions, it should be known that 1,000 milliliters is 1 liter. So what goes on the top, what goes on the bottom? Well, I need to cross off the liter, so I'd put the 1 liter part up the top here. And then underneath that, I'm going to have my 1,000 mils or milliliters. Okay, now I've got my liters crossed off. And at this point, if it's becoming a little bit less obvious what's going on, maybe we might cross a few of these off so you can see the approach. And it's always good to cross off to double check. So as I said, we've got rid of the liters here. We got rid of the gallons here. So currently, as it stands, our units are actually pounds per mil or milliliter, pounds per milliliter. So I'm going to do the next portion of the problem here, and we're going to convert from the mass of pounds into grams. Okay. Now, in the conversions, again, we don't have grams, but we've got kilograms. So where does the pound part go? It's going to go on the bottom. For the conversion, it's 1 pound. And hopefully I've left enough room, but that's going to be so just enough room there. 0.4536 kilograms. Okay. And then we know that the answer's going to have grams rather than kilograms. So 1,000 grams is 1 kilogram. So it's in the denominator, sorry, numerator here. And I can again cross off those. So I've got rid of my kilograms. And now, and I've also got rid of my pounds here and here. So now I'm in the grams per mil or grams per milliliter. Okay, which is what we want. So this time I do have numbers other than 1 in the denominator. So when I put in the calculator, I'm going to type in 55 times 0.4536 times 1,000 divided by, and then I open a parenthesis, 3.79 times 1,000, close parentheses, and equals. And so I get 6.5826. That's five significant figures. And the units always report the units. So they're going to be grams per mil. Okay. So the question though is that the right number of significant figures? And so we can tell from here that 55 is 2 significant figures. So we really need to report the answer to 2. We can just check the conversion factors, and it's worth running through here. So this first conversion factor is actually to 4 significant figures. And the second conversion factor is to 3 significant figures. Again, we don't count these numbers here as one significant figure because this is the quantity we're getting and then relating it to another quantity. So this is 3 significant figures here, but we have to report the answer to 2 for the 55. So we'll get 6.6 grams per mil. Like that. Okay, so the last problem is a bit trickier. We don't have the conversion factors here. We know from a previous question, we know a conversion between between centimeters and inches, and so we can use that. A lot of this is going to assume we know those relationships between a foot and an inch, and a relationship between a yard and a foot. But before we get onto this problem, I've got this 3-dimensional grid here, and so this will help us understand what's going on. This grid has 10 cells or little cubes across, I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 here. So say in a linear relationship, a certain distance will be split into 10. Well, that same relationship, when it's extended to 2 or 3 dimensions, isn't still 10, okay? So, for instance, say 1 centimeter is 10 millimeters. So the conversion from a centimeter to millimeter would be a relationship between a tenth, or using 10 in the conversion boxes. But if we wanted to then go from cubic centimeter to cubic millimeter, that then would be a relationship of 1,000, okay? And the reason is because you can see with this cube that it would be 10 times 10 times 10, okay? 10 times 10 times 10, because we have our length, width, and height to consider. So this is obviously blown up, but if this cube, not the little boxes, but the overall cube was 1 cubic centimeter, it would have 1,000 cubic millimeters, for instance. And so in this problem, we're not discussing millimeters. We do have centimeters, though. We're not discussing millimeters, but that cube was just to show you the relationship. When you extend from 1-dimensional to 3-dimensional, you have to cube everything. So set this problem up. So we're looking at 2 cubic yards. I'll draw some conversion boxes here. In the text. So 2, then we have our cubic yards. Okay. Now, we need to eventually get to centimeters. So we need to probably convert this first to feet. Again, on the bottom here, I'm going to have the yards cubed. Okay. So I know that my first part here must have the cubic yard. I'll leave that there for a second. Now, I know that there are 3 feet in 1 cubic yard. So I'll put the 1 for the cubic yard because that's a conversion. But when I go to put in the 3 feet, if I'm trying to relate cubed relationship here now, I really need to be considering cubic feet. So if I cube feet, I also need to now cube the conversion of that. So hopefully that makes sense. But basically, if you go to convert from a linear relationship to three-dimensional or two-dimensional, then you must factor that in. So in this case, we're going from a one-dimensional to a three-dimensional, and so I have to cube the number. So if I write it on the side here, just to give another demonstration here, or maybe I'll put it there. If we were looking at, say, 1 yard equals 3 feet, what I'm saying is if I wanted to then relate it in a cube fashion, I would have to cube all of these values. So I'd cube the feet, I'd cube the 3, I'd cube the yard, and I'd also cube the 1. So you cube everything. But 1 cubed is just 1 times 1 times 1, which is just 1. So I've sort of left it off in the conversion here. So that's sort of why it's not there, but you could put it there if you wanted to. So you could put that there, but it's not really needed. So moving along, we're currently in cubic yards have been crossed off, so we're currently in cubic feet, but we want cubic centimeters. So then we've got to convert the feet to centimeters, but we'll go through the inches first. So we know from above that feet to inch relationships here. So when I put down my 1 cubic foot, the conversion, again, this could be a 1 cubed, then I'm going to have 12 inches normally for a linear sense, but because we're cubing, it's going to be 12 cubed and then inches cubed. Okay. So I might cross a few of these off so we don't lose track. So I've got my cubic feet crossed off. I've got my cubic yards crossed off. And now we've got to convert from the inches or the cubic inches to the cubic centimeters. I'm going to want the cubic inches on the bottom. I know that 1 inch is 2.5 is 2.54 centimeters. So 1 cubic inch, again, the 1 would be cubed. So maybe I'll draw that in this time. So the 1 inch cubed is going to equal 2.54 cubed centimeters cubed. Okay, so now we are in cubic centimeters, which is what we wanted. Again, I'll just cross these off just for demonstration. Okay, and now putting in the calculator. I'm familiar with the power button on my calculator, and so it's reasonably easy. But even if you weren't, or you weren't sure exactly what to do with the calculator with the power button, you could always just multiply in the numerator 2 times 3 times 3 times 3. That's what 3 cubed is. Times 12 times 12 times 12 times 2.54 times 2.54 times 2.54. If you liked, or you could just use the power button if you're familiar with that one. So 2 times 3 to the power of 3 times 12 to the power of 3 times 2.54 to the power of 3. And then there are no other numbers aside from 1 in the denominator here. So from the numerator, I get this number. And you probably wouldn't worry about writing it all out like that. But we're going to look at our number of significant figures. And in this case, we're really at one significant figure because the problem had two, not two significant figures, but the number two, and that is only one significant figure. So the best way to do this would probably just be to use scientific notation, particularly because we're going to have so many zeros. So it would be okay to put 2 million. That would be okay. But in this case, we'll just use scientific notation. Either way would be correct, though, but we'll just use scientific notation for this particular example. So that's going to be 2 times 10, and then to the power of 6. Let's have a look at y. So if I looked at my decimal point here, I'd have to move it over 1, 2, 3, 4, 5, 6. I have to move it over 6 times to get to this spot here, which would take you to 1.529. But we can only report the one significant figure, so that will get rounded up to 2. And that's how many cubic centimeters we'd have. So as you can see, these unit conversions are reasonably straightforward. It's just a process we have to follow. And as long as you stay systematic with that, and as long as you make sure that wherever you're going from one conversion box to the next, you're always looking to cross off units, you should be able to keep track. And sometimes it may not be readily apparent, especially if you've got, say, like the example I showed, from kilograms to grams or liters to milliliters, and you're not quite sure how that fits. If you make that start with it and think about how that might be related, you know, in those cases, it was by a factor of 1,000. It should all be doable as long as you keep that systematic approach. Thank you.